So in our lesson today, accentuate the negative 2.2, we will start subtracting integers. So we're going to start with the story problems that are on page 24 and working with our chip models to see what's actually happening as we subtract our integers. Okay, so in the first problem, we have this girl, Kim, and she has 9 CDs. Well, she sells 4 of her CDs at a yard sale. All right, so we take away 4. 9 minus 4 equals 5. All right, that's what we've always known about subtraction. We start with an amount, you take away some, and then you find what is left. Okay, well, we can also do this with positive and negative integers. So on the next example, we have this guy, Otis. All right, he earns $5 while he's babysitting. So represent $5. Now he owes LaToya $7. All right, so he's going to pay her his $5 that he earned. To represent this on a chipboard, to subtract the 7 from 5, we'll have to start by showing the positive 5 as, now I have to go back and forth between black and red. Okay, because we've got red. Okay, there's red. Start by showing the $5 as the black chips, which is positive. All right, so let's flip these over to yellow. All right, we can't take away 7 because there aren't 7 black chips to remove. Since adding both a red chip and a black chip does not change the value of the board, add 2 black chips and 2 red chips. All right, so in this case, yellow and red. Okay, so he starts off, he earned his $5 babysitting, but he owes her 7. We couldn't take away 7, so we had to add 2 of each color to keep it balanced. All right, so now we can pay her 7. So we take away 7, and what are we left with? A negative 2. Okay? He still owes LaToya $2. All right, so let's practice a couple of these. We'll start with basic problems, and then we'll move on to some more advanced. So let's just say we have a 6 minus 2. All right, let's put that in chips. So that's a positive 6. I can't find the black for the board, so we'll just use this. There we go. All right, so we have a positive 6, and we want to take away 2. All right, so just take away 2 of them, and we're left with 4. All right, and that's something we've always known. All right, now let's say we start with a negative 5, and we want to take away a negative 3. Okay, so let's use our chips. So we need a negative 5. All right, so we have 5 negatives. We need to take away 3 of those negatives. Do we have 3 negatives to take away? Yes. Yes, we do. So all we have to do is take them away. And what are we left with?
Negative 2.
We're left with negative 2. All right, I'm going to put these in dots so they'll be permanent. So we had a negative 5. Let's say absolute value of 2 minus 3. Okay, so here we have an integer problem that's in the absolute value sign. So we have a positive 2, and we need to take away positive 3. I don't have positive 3. So I have to add one of each color. There. Now I can take away 3. And what am I left with? What is this? Alright, so that goes in the absolute value, -1. Alright, so what's the absolute value of -1? 1. And that's your answer. Alright, what if I did the absolute value of -6 minus 2? Alright, so starting with -6. Alright, so there's my -6, but I need to take away a positive 2. Hey, and here's something you really have to focus on here, because I think a lot of you would want to go, okay, take away 2. And that's not going to be correct, because it doesn't say to take away -2. It says to take away positive 2. Alright, I don't have positive 2 on the board. So we have to add the positives, 2 positives, and add 2 negatives. Alright, so now I can take away 2 positives. And what am I left with? I'm left with a -8. But if I'm finding the absolute value of -8, it is 8. One more. What if I want the absolute value of -1 taken away -4? Okay, starting with a -1. And I'm going to have to take away 4 negatives. I don't have 4 negatives. I only have 1 negative. So I have to add how many to get it up to 4 negatives? 3. Add 3 negatives. And to keep it balanced, I also have to add 3 positives. Okay, so now I can take away my 4 negatives. Take them away. I'm left with positive 3. Absolute value of positive 3 is 3. Okay, I'm going to give you 4 problems to try on your own, and then we'll check the answers as a group. This is on page 27, part A, solving group 1. So the first one is 12 minus 8. Then we have -5 minus a -7. Then we have a -4 minus -2. And finally, a +2 minus a +4. All right, work in your groups to answer those, please.
push it off. I don't know how to fuck it.
Alright, let's try these. Alright, so 12 minus 8, that's what we're used to doing, no problem. That's a 4. Alright, and by the way, feel free to use the chips as long as you need, and if once you don't need them anymore, then put them away. But even on your test, you'll be welcome to use the chips if you'd like, okay? No calculators on the test, but you can use chips. No, if you just did this in your calculator, what am I grading you on? Punching correct numbers into a calculator? Because it would all do it for you. Yeah, no. No. Alright, here we go. Thank you to those of you who are listening. So we start with a negative 5. Okay, and we need to take away a negative 7, but we don't have negative 7. So we need to add 2 more negatives and balance it by adding 2 more positives. Alright, so now I can take away negative 7 and I'm left with a positive 2. Next one, I have a negative 4 and I need to take away a negative 2. There you go. I'm left with negative 2. Finally, I start with a positive 2. And I need to take away a positive 4. Okay, I don't have positive 4. So let's add 2 positives, balance it by adding 2 negatives. Now I can take away positive 4. And I'm left with negative 2. Okay, one more set and you'll be ready for your independent work. Alright, here's the second group. -12 minus negative 8. Negative 5 minus a positive 7. Negative 4 minus 2 and a positive 2 minus a negative 4. Alright, so we have our negative 5. We're taking away 3 of those negatives. 1, 2, 3. Leaves us with our negative 2. Okay? What if we start with 2 and we want to take away a negative 3? Okay? Starting with a positive 2. But we need to take away 3 negatives. Do I have 3 red chips up here to take away?
No.
Alright, how do I do that?
You add 1.
Now I add 3 of them. But when I add 3 red, to keep it balanced, add 3 yellow. So I added 3 red And I added 3 yellow. Okay, so now I can take away my 3. I had my 2, now I have to take away my 3 red. What am I left with? What's on the board? 5. Okay, now here's the place in the video where it says 2 wrongs make a right. Because look, I have wrong and wrong. So really all I did was add these 2 numbers together to get a 5. Yes, Jane?
What if you have a -2 minus a -3? Will those 2 negatives make it?
Let's try it. Let's try it. All right, let's say we have a -2 and you want to take away a -3. Okay? We have a -2. All right, can I take away 3 negatives? No, because I don't have them. What do I do? I don't need to add 3 of them because I already have 2 up there. I need to take away -3, but I already have 2. So I'll add 1 negative, and I have to keep it balanced. I have to add 1 positive. So that would be, okay, I started with 2 negatives. And then I had to take away the -3. But to do that, I had to add 1 red and 1 yellow. Alright, so now I started with my -2. Now I can take away my -3. And it'll leave me with a +1. Another way of thinking of that is if we were on a number line, and we were at -2, so I'm going to get rid of -3. Think about maybe like if you're taking away something negative, that's going to turn into positive because you're getting rid of the negative in your life. So you head into the positive direction by 3. 1, 2, 3. Put you right here at that +1. Yes, Hannah?
You put 5 and 2 on the
Is there a mistake that I'm not seeing?
You put 5 on number 2 of the positive now.
Here?
No, that.
Here? Because remember we started with 2, but we had to take away a -3, but we didn't have a -3, so we had to add in 3 negatives, and we had to add in 3 positives so that we could take away the 3, and that's why we ended up with 5 yellows. All right, and one more. Okay, we have a -4, and we want to take away a +2. All right, so start with -4. Okay, but we need to take away +2. Do I have any positives on the board? I don't have any positives on my board, so how do I do that? Okay, I'm going to have to add the 2 positives, and to keep it balanced, I add 2 negatives. I know it's hard to see for you guys because my screen's yellow. Alright, so now I can take away 2 positives. And what am I left with? 1, 2, 3, 4, 5, 6 red. Do I need to do that one again? Okay. Alright. Let me just do another one that looks like it. Alright, let's say -3 minus +1. Alright, so start with your 3 negative chips. Do I have 1 positive to take away from this group? Do I?
No.
I don't see any yellows. Alright, so if I'm going to take away a positive, I have to add a positive. To keep it balanced, I must also add back that negative. Alright, so now I can take away my positive and I'm left with 4 negatives. Thinking about this one on a number line. Okay, so if we started at -3, and I have to take away a positive, so that means I have to go in this direction, but I'm only taking away 1, it lands me at a -4. This lesson also wants us to remember absolute value. So just to refresh our memory one more time, absolute value is how far a number is away from 0. So whenever we give the absolute value of any number, it will always be positive. Because we're just saying how far is it away from 0. So the absolute value of -77. How far away is it from 0? It's 77 away. Alright, what if I take the absolute value of 9? What's that one?
9.
Okay. Something else you might start to see is problems within the absolute value. Let's go over for this sample. Flip it. See, there's my arrow. Alright. Alright, here we go. I'm not going to have enough chips to represent this. Alright, so we start with a +12. And we want to take away -8. Now, if we think about it as 2 wrongs make a right, we just change this to, we'll get a +20. On this one, we start with -5. But we need to take away a +7. I'm not going to have enough to add these either. Alright, so we'll end up with -12. Here we have a -4, and we're taking away a +2. -4. I don't have any positives, so I need to add 2 of each. Now I can take away +2, and I end up with a -6. Finally, I've got a +2 And I want to take away -4, so that means I'll have to add 4 of each. Now I can take away my -4. I'm left with a +6. Or I could think of 2 wrongs making a right, changing that to adding, and getting 6.